All right, let's get through this quickly, okay? So we have Elise can run 4.5 miles in 1 hour. All right, okay, so when we compare the number of miles and the number of hours, it's a proportional relationship, and it looks like here's our equation. How do we end up graphing this proportional relationship? Well, we know that we can see that the x is going to be the number of hours. All right, so we're going to say this is the hours she runs, and this is her distance. Okay, make sure you label the x and y axis, and then we have a proportional relationship, so at 0 hours, she's at 0 distance. Now the problem is that we won't get much written on this if we go up by 1 each time, but that's okay for this example. Okay, if we could just go up by ones, okay, we're not going to get very many hours in. All right, so it might be better to make these intervals a little bigger so that it shrinks down the steepness, so it goes, we can fit in more points. But if you did it by 1, that's okay. We'd go up at 1, it'd be 4.5 miles, and then in 2 hours, we'd be at 9. Now we could do this several ways. We can say, oh, hey, look, I see the slope of 4.5 every hour. So you could just start at 0, 0, because we know that point in a proportional relationship, and go over an hour and up 4.5, over an hour, up 4.5. We could also make a table, which we know it starts at 0, 0, and then 1 would be 4.5 and plot that point, and 2 would be 9 and plot that point. Okay, so multiple ways to graph this, but mostly common sense on how to graph that. Here we go, on to part B. Okay, it says interpret the slope. So the slope would be every 1 hour, it goes up 4.5. So rise over 1, right? 4.5 over 1. And what does that represent in this situation is what interpret means. Okay, so interpret means okay, the slope's 4.5, but what does that mean when it comes to this real life situation? Okay, so the slope of 4.5 represents a unit rate of 4.5 miles per hour. Okay, and we can write a little bit further. We can say 4.5 miles per hour is how fast Elise can run, but it's just basically giving it units and telling me what the slope represents in the real life situation. Okay, so interpret often confuses people, but it's pretty simple. Just go back and see what it meant up here, right? 4.5 miles in 1 hour. So now, let's see, we have a proportional relationship between the number of hours Jeremy works and the amount he earns. Okay, so we know that this is, now we just have to complete the table. So it says this year Ann earns $10.75 for every hour he works. So 2 hours would be 20 plus $1.50, so that's $21.50. And then the next one would be another $10.75, so that takes us to 31, and then add another 75 cents, so that takes us to 32.25, and then we're going to add 10 to that, so that's going to be 42, so 43. Okay, all you had to do was complete the table. There we have it. All right, next, going down to this one. Okay, there is a proportional relationship between the number of tiles bought. Now, this one is confusing because they use 2 units, and so it's a little bit confusing. They talk about tiles, but then they talk about square feet. So which is it? Let's read it carefully. Jared is tiling his kitchen. He wants to buy tile at the cheapest price. The local hardware store sells tile for $5.25 per square foot of tile. All right. The cost at the mega store is shown in the graph. So really, this shouldn't be number of tiles, so you can cross that off. If that was confusing, I apologize. It's actually square feet of tiles. Okay, so how many square feet do you have to buy of those tiles? Okay, so then we can have, right, the one store sells it at $5.27 per square foot, and then this store we can figure out their per square foot unit rate. There's a constant relationship between the number of tiles bought and the cost of the tiles. So then again, there's a confusion here. This says number of tiles and per square foot. So it's not going to be right number of tiles there. We have to change that to square feet. Okay, to the cost of the tile. What is the cheapest price Jared will pay for 100 square feet of tile? So we're comparing local hardware store and this place called and the Mega Hardware Store. All right, so local hardware versus Mega Hardware. So that's going to be the total cost is equal to $5.27 times the square feet of tile that you buy. And then how do we write this equation? Well, y equals, okay, that's going to be, remember it's proportional, so we know that wherever 1 is, this is our unit rate or our constant of proportionality, so 5.35 per square foot. All right, and then it asks, what is the cheapest price they will pay for 100 square feet? Well, if it's, we're going to go with this place, the hardware store, the Mega Hardware Store doesn't have the best price this time because they're that much per square foot. So we're going to plug in 5.27. We're going to plug in the 100 in the place where tiles go. And so the total cost is going to be $527. So $527 is your cheapest amount you can purchase those for, the tiles for. Okay, that was really confusing because they compare number of tiles to square foot of tiles. Yeah, that's what the book had, but I'm going to have to go in and edit that. Sorry about that. Okay. All right, all we're doing is finding the slope of the line. I noticed that a lot of people went from here to here to find the rise over run. Notice that this doesn't hit a corner, but it's pretty obvious where it hits. So, right, that's 3.5 up to 7. So that's a change of 3.5, a rise of 3.5, and then a run of 1 pound of grapes. Okay, so that's 3.5 for 1. Now, some of you are like, wait, which one is it going to be? What's equivalent to 3.5 to 1? Okay, which of these is it? All right, well, if you just divide these, which one equals 3.5? This one would. So that's the answer. Some other ways to connect to it is that if you went, let's say, from the bottom, 0, 0, all the way up to here, okay, that rise and run would be 7 to 2. So you can see that is the rise over run is 7 over 2. Another way you could think about it is equivalent ratios, so times 2 and times 2. So if you can get 1 pound of grape for $3.50, then you'd get 2 pounds of grape for $7. So you can see that as well. All right, so might have confused you at first, but then you can see how we have to look for equivalent ratios. So this has to be equal to one of these equations along that they give you. So this is the one. All right, moving on. All right, find the slope. Well, we have our slope formula. I like to write them out and label them. Okay, so this is my first point, so I call it x1, y1. This is my second point, so I call that x2, y2. And then I have my slope formula. So that's m equals the change in y, which is subtract the 2 y coordinates, and the change in x, which I subtract the 2 x coordinates. Okay? And then I can plug those in. So 10 minus 7 over 7 minus 3. And then that gives me 3 over 4. So we have a slope of 3 over 4. On to the next one. Here we go. All right, describe the slope by writing 0, positive, negative, and undefined. Okay. Remember Slope Dude? He just comes down the slope and then falls off the edge and says the terrible words that nobody in math should say. Undefined. All right, so that vertical line, it doesn't say to do this, but just as extra practice, the equation there would be x equals 2. Undefined. Okay, this is a positive slope. Remember, Slope Dude always travels left to right. So as we go this direction, all right, y is increasing, x is increasing, y is increasing, so it's a positive slope. And here we have our slope of 0. That's zero fun to trudge along on a flat ground on skis from Slope Dude. And we have our equation for that just for fun. It doesn't ask for it, but it's always going to be y equals for a horizontal line, and that's y equals 1. Because all the points along that line have a coordinate, a y coordinate of 1. And then this one, of course, is negative. Y is decreasing as x increases. All right, moving along. Okay, this one got us a little confused, but we're comparing rocket A and rocket B, their power consumption. Okay, this gives us the relationship in the form of an equation, and then we have the table here. Okay, so part A says which will use less power for a trip that takes 6 hours. Okay, and so rocket A, okay, their power is determined by 1.8 times the time that they take, and we're wondering about 6 hours. Okay, so when we do that multiplication, all right, 6 times 8 is 48. Carry the 4, that's going to be 10.8. So the power for 6 hours is going to be 10.8 kilowatts. So how do I know it's kilowatts? Well, I read carefully up here, power consumption, P in kilowatts. Okay, so that's rocket A, and then rocket B, very simple. I feel like it's so simple that you might have missed it, but they give it to you right there. For 6 hours, it's going to be 9 kilowatts of energy. Okay, so that's 9 kW. Actually, I think it's a lowercase k, lowercase k, capital W. Okay, 9 kilowatts, where this is only 10.8 kilowatts. So which rocket? Rocket B uses less energy. And how do I know? Because I calculated it for each, and I found out that rocket B uses less. Okay. What would the power consumption be for the rocket that uses less power? That's referring back to this 6 hours. And so rocket B uses 9 kilowatts of power. Okay? Now, moving on, consider the table. Is the relationship between the two quantities linear? We know it's linear if it has a constant rate of change. And so we check the change. It goes up 1, 1, 1, 3, 3, 3. Okay, so that's a constant ratio. All right, now if we were just to do 7 divided by 2 and 10 divided by 3 and 13 divided by 4, we can't do y divided by x, or the ratio of y to x is not equivalent. So therefore it's not proportional. But the rate of change, right, the ratio of the change of y to change in x is the same. So that means it's linear, just not proportional. Okay, so yes, it's linear. Find the constant rate of change. Well, we would do the rise, or the change in y, over the change in x, which is going to be 3 over 1, so that equals 3. All right, constant rate of change. Now, we got this one. The cost of banana varies directly. That means it's proportional. So, and this is, remember, the first one listed as y. So y varies directly with the number of pounds, so that would be x. If 7 pounds costs $5.46, find the cost of 3 pounds. So if it varies directly, then we can just find that unit rate by dividing y by x. All right, so the cost divided by x, which is pounds, so that's 7. And let's do the math there real quick. So we're doing the math real quick. It goes into 6 times 48. Oopsie. Yeah. No, that's wrong. Sorry. Yeah, sorry. 7 times, my bad. 49. Okay, so that's 56 here, so that's 8. So then we have, it looks like 78 cents per pound. LB. All right, then we just have to multiply that by 3 because that's our unit rate and 3 pounds. Now we could make an equation and set that all up, but I don't think we need to do that. So that's 4, 21, 23. So our cost for 3 pounds would be $2.39. Okay, equation of this line. Ooh, it's tricky. All right, what is our y-intercept? Well, we're looking along this y-axis here, and we see the line crosses right there at 1, 2, 3, 4. That's 0, 4. So that's our y-intercept. So these guys are out. Peace. Now, what is the slope here? So let me erase this so it's a little clearer. Got to find 2 nice points. Let's see. If I follow this line up, where does it hit a beautiful corner of a box? Well, right there it looks like, and then right there on our y-intercept. So I go up 1, 2, 3, 4, 5, 6, and over 1. So that's 6 over 1 for rise over run. So there we have it. All right, we have our y-intercept of 4 and our slope of 6. All right, describe the side lengths of each triangle in the graph. Oh, how they relate. So we have to describe how the side lengths of each triangle relate to the slope of the line. All right, well, the vertical line is like the rise, and the horizontal line is like the run. So the rise to run. All right, so for the triangles, okay, the ratio of the vertical side to the horizontal side of the triangles. All right, the ratio of the vertical side to the horizontal sides of the triangles is equivalent and is the same as the ratio of rise to run or the slope of the line. Okay, so it's saying how are the sides related to the slope? Okay, and the ratio of 2 sides are just like finding the slope of that line. All right, keep on moving. We're getting there. All right, we got directly proportional. Okay, so the amount of money, Y, is directly proportional to the number of hours, X. How much does Eric earn per hour? Well, we can get any point, but it looks like it's 1,750. If we're not quite sure, we can look at another point. Oh, nope, sorry. I thought in between it must be 50, but I didn't realize it went up by 2's, so that's actually exactly 7. And I came to that conclusion. I fixed my mistake by checking this and saying, oh wait, that's 2 and 14. So for them to be equivalent, I had to re-look at this and be like, oh, that's supposed to be 7. Okay, so we always find the unit rate for a proportional relationship by doing y over x, or finding that point 1, r. Okay, so here is our unit rate, or we can divide 14 divided by 2. Either way, we get our unit rate. Okay, graphing this, always like to make sure that my axes are going up by 1s before I graph to make sure I don't mess up. So we start by graphing the y-intercept of 3, and this is a positive slope. So we're going to go, if it's 1 and 3, that means we're going to rise 1 and run 3 from that point I already did. So let's see here. We got up 1 over 3, put a dot. Now I can't put another one, so I'm going to go backwards. Okay? I'm going to go down 1 and right 3, or sorry, left 3. All right, and get my other point here. And then I can draw my line. Oops. I'm trying to rush, so I'm not going to get a straight edge, but I'll give you straight edges for the test. Okay. Ah. Okay, that's not great, but let's keep going. Keep it moving. Okay, now this one's a little tricky because you're going to have to, oops, it's going to be a little bit too, there we go. Let's trim it down here. All right. So I had one person ask, wait, I can't graph that because when I look here, I only go up by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I won't have room to put a y-intercept of 10 and then also increase by 2 every value of x. Okay, so that means we're going to have to change up our intervals a bit. All right, so that means we're going to just have to count up by bigger numbers on the y-axis. I don't know why this isn't going away, but hopefully it goes away. Okay, so 10. Let's just real quick interpret all this so we know what we're graphing here. Okay, remember it says the cost of a shirt is y. So this is going to be total cost. All right, and then y is x hot dogs. Okay, so this is going to be number of hot dogs. Okay, that helps me, and it puts it in context so I know what's going on here. And so X hot dogs and a souvenir hat. So what do you think that souvenir hat, right? If we, in this equation, if we bought 0 hot dogs, how much would we still have to pay? So, right, y equals 2x plus 10. Okay, x is hot dogs, so 0 hot dogs, 0 times 2. We're still paying $10. So what do you think that $10 represents? Okay, it's our initial value, or it's, in this case, the amount of money we paid for that souvenir hat. Okay, so now we have to graph, and we can't fit it if we only go up by 1. So we can go up by 1s over here. And sometimes you're just going to have to try it and then make a mistake and erase it and try again. Okay, here we can go up by 2s. 4, 6, 8, 10, 12, 14, 16, 18, 20. All right? And at 0 hot dogs, we still bought the souvenir hat. But then what happens every time we buy a hot dog? The cost goes up by what? $2, right? $2 per hot dog. So we're going to go up to here and then up to here because the increase, I know you might think the slope is 2 over 1 and go up 2 blocks, but because each block is 2, worth $2, right? Every time we go up, we're going up actually $2 here, right? From 10 to 12. We can just go up 1 block because each going up 1 block represents $2. Okay, so that's how we can graph it, and we have to understand that we have to change that interval because the graph given to us does not fit if we go up by 1s. Okay, write an equation in slope-intercept form. So we're doing y equals mx plus b is slope-intercept form, where this is the slope and this is the y-intercept. We find our y-intercept first. That looks like -3, so it's going to be -3. And then we find 2 nice points. It looks like there. I just check with other points to see if it keeps going by that same rate. It does. That's a rise of 2 and a run of 1. Sometimes I like to go this way so I can see 1 and 2. That's positive and positive. So I put my rise over top of my run, 2 over 1. So that gives me a slope of 2, x. Oops. Usually it's plus, but since this one's negative, it's going to be minus. Okay, so there is our equation for that. Moving on. Okay, we have the members of the basketball team are selling t-shirts during Spirit Week. The cost is $20 for the design, and $1.50 to print each t-shirt. The cost, Y, to print X t-shirts is represented by this graph. Okay, interpret, it just tells you, well, you're just saying what does the slope mean and what does the y-intercept mean in the context of the problem. So the slope, we know, slope equals 1.5, and what does that represent? Okay, well, that's our rate, our unit rate, so that's 1.5, or $1.50 per t-shirt. You're just telling what it means, what it represents. And then your y-intercept equals 20. What does that represent? Okay, that is the initial value, right? The cost for the design, right? You have to pay for the design. Once they design it, you haven't bought any t-shirts yet. So X is still 0 at that point. Okay, so you're at 0 t-shirts, you already spent $20. You just pay that once. Then you add to that cost every t-shirt you purchase. Okay, or you want to print, I mean. Okay, so that is my initial value, and that's $20 for the design, and that's what we call the initial value, right? Only happens once, happens before you've done any of the variable that's increasing. All right. On our way, we're getting there. Okay. The toll varies directly with the number of cars on the road. So the toll varies directly. So our with the number of cars on the road. Now, they really kind of threw a curveball at you here. Okay, usually we think, okay, the one they say first is Y, and then the one they say next, number of cars, is X. But then they wrote the table in the opposite of how we usually have it. So really, we should think of this as as Y, and this is X. Okay, and then we're going to go on from there. So I wish they had taken this and put it over here. Okay, so now we're going to write you see? Okay, so this is the problem here. The toll varies directly with the number of cars. They should have written this opposite. Okay, so this should have been written the number of cars on the road. No, that's wrong too. All right, well, it says write an equation in slope-intercept form that relates the toll X for the traffic volume Y. All right, so if traffic volume is, so we're going to do, right, since it's direct variation, we're going to divide our Y by our X. So that's 508 divided by 1. All right, so that means that it is, that's our constant of proportionality. So it's going to be 508x. What does that mean? That means that this is $1 for every 508 cars. Okay, right? 508 cars equals $1. So if we put, if you drive by the toll booth and it says $4, well, that'd be how many cars do you think are on the road? Well, you do 4 times 508, which it says right here. Okay, don't love how this one's written. It wrote it in, the opposite way that it typically should. Okay, but now we have it set up, and find the number of vehicles per hour at peak time if the toll increases to $6. Okay, so how many cars would that be? 508 times 6, and then we can do that math. 8, 4, wow, that's going to be 3,048 cars. All right. Moving along. Okay, the table shows that the points that lie on the line use the slope table shows points that lie on a line. Use the slope and y-intercept to write the equation of the line in slope-intercept form. Okay, y equals mx plus b. So y equals, we could find our slope by finding the change in y over change in x, 5 to 1, 5 to 1, 5 to 1. Okay, so that's going to be a ratio of 5 to 1, which is 5. And then we find our y-intercept by looking for when x is 0. And that looks like y is 2. There we have it. That was a little more cut and dry than the last one. The slope of the line by, find the slope of the line by comparing the change in y to the change in x. So we have a run of 3 and a rise of 2. So the change in the y is -2, the change in the x is 3, so there's my slope. All right, we have a bed and breakfast here, charges a one-time deposit of $30 plus $90 per night. Another bed and breakfast hotel charges a flat rate of $105 per night. Daisy wants to book a hotel for 5 nights. Which hotel costs less to stay? So we got one bed and breakfast charges, so the total cost is going to equal $90 per night plus the $30 initial fee. And the other one, it looks like a proportional relationship, and that would just be $105 per night. Okay, so we have our two relationships, and now which will be less for 5 nights and how much less? So x is our nights, so we're gonna plug in 5 for that, and we get, that's gonna be 450 plus 30. So for 5 nights at this hotel or bed and breakfast, it's gonna be 480, and then this is gonna be y equals 105 times the number of nights, which is 5, and that's going to be y equals 525. All right, so this guy, let's see, a bed and breakfast hotel charges that much. So the first bed and breakfast hotel charges the least. The first hotel charges the least by, let's see, the difference there would be $45. All right, and that is it. Whew, it took much longer than I thought it would, especially with those curveballs that the book wrote this test, and whew, made some errors on the way that they phrased their problem. So I might have to take that one out of the test because it's so unclear. But otherwise, hopefully that made it clear. Come in with questions for advisory, and let's make test days the best days.